1.4, measure and classify angles. A lot of vocab to start us out with today because we're kind of taking a break off those segments, lines, and rays, and we're going to go into angles today, okay? So an angle, the definition here, it consists of two different rays with the same endpoint. So if you take a ray, which remember is an endpoint and it goes in one direction, and you go back to the same endpoint and you do a second ray, in between there, what you have created is this angle, okay? So this is the angle inside between those two rays. The sides of the angle are the two rays that make up the angle. So you have side 1 and side 2. To be honest, we don't do a lot with those sides. They just contain it, okay? Because remember, they're rays. They go on forever. We can't measure the side there. The vertex of an angle is this vertex right here, this point where the two rays meet and share. Measure of an angle. This is one that it's kind of funny. They put this vocab down. It's kind of like, what do you want here? If you look it up in the back of the book, there's this huge definition. Here's some things I want you to know about the measure of an angle. It's measured by a protractor. Okay, we have a protractor on our handy dandy geometer. Some of you may have one that's usually looks like a semicircle shape or something like that. It's measured in degrees. That's how we label it. And it's the distance between the rays of an angle. Now, one of my favorite questions to ask in class is I'll draw you this angle, and I'll ask you this question: where do I set my protractor? Where do I measure? Do I measure this right here as close as I can to the vertex? Do I need to measure as far out as I can from the vertex? Or somewhere in the middle? Where do I measure with my protractor? And what am I really measuring? Okay, that's kind of what you're thinking when you do this. It says the distance between the rays of an angle, but it's measured in degrees. Well, keep reminding yourself that if you have a circle, all the way around is 360 degrees, okay? So this is just a portion of that 360 degrees. It's asking you kind of like how much of the circle are you looking at? It's got to be less than 360, right? Okay, and then I ask you the question, where do you set your protractor? I'm going to be perfectly honest, and it'd be super nice if I could pull a protractor out right now on this screen and show you, but I can't. So I'm going to kind of use my highlighter maybe to stress my point. I'll be honest, you use your protractor and you set the vertex of your angle with your protractor. That's this like where you set it at, and I'll hopefully show you in class where we set those at. And then basically it's how big is your protractor, right? If you have one of those little handy dandy, the ones that are half a circle like this, you set it down. Where does it land? I'm going to be honest, if this is the way it works, then you're going to measure your protractor, you're going to use that, and you're measuring right here because that's what matches your protractor. All of these measures would be identical because all of them are saying how much of the circle. So this is how much of a tinier circle, this is more of a medium, this is a little bit bigger, and this is an even bigger circle. So it really doesn't matter where you measure it. What it matters is how big your protractor is. That's what really sets where you measure an angle at, okay? So just kind of a food for thought there, that don't worry about where, you're just saying how far open is it between those two rays. That's kind of what the measure of an angle is finding. Okay, so we have some different angles that we are going to work with. The first one is an acute angle, an angle somewhere between 0 and 90 degrees, okay? And most of you have worked with these vocab before, so these are not new to you. Okay, so acute, something like this, right? It's smaller than 90. A right angle is one that measures exactly 90. Okay, and you'll often see us put that little right square right in there. Obtuse angle is between 90 and 180. Okay, so something big. And then a straight angle, this one might be a new one for you, is an angle that measures 180. It's kind of interesting to think there's a vertex. Here's one ray. Here's the other ray. Okay, and this angle is actually all the way here, and that's called a straight angle, and it measures 180. Okay, congruent angles, two angles with the same measure. Just like congruent segments were segments with the same measure, congruent angles are angles with the same measure. And remember, if we want to find, if we're talking about the angles themselves, the objects, they are congruent. If we're talking about how big they are, their measure, it would be equal, and you're only talking about one at a time then, okay? And an angle bisector is similar to a segment bisector. It's a ray that divides an angle into two congruent angles, and it bisects, it cuts it into two equal parts, okay? All right, so that's our vocab. If I move too fast, pause the video, copy down what you need to. And remember, there's no vocab quizzes. It's just you need to know the meaning of these words. Okay, so let's look now about naming angles. Okay, we talked about a lot about naming a point and a plane and a line and a ray and a segment and the different symbols. So when we name angles, we need to come over here and use a name. So on the bottom of the page here, I wrote you a note that tells you how to name an angle. So check, I don't remember if I put it on the bottom of your page or not, or if you need to copy this. But to name an angle, we're going to use the angle symbol, which is kind of like that slanted L, and then 3 letters from the angle, 1 from each ray and the vertex in the middle. Okay, so that's our rule for naming our angles. So I ask kids too, and again, these are ones that I really wish we were in class together to be able to answer this, so you could look at this and you could say, but we have this discussion. I have you look at this picture and I ask you how many angles are in this picture. Now some of you are quick to say, well, I see 2 angles, and I'm with you. I see 2 angles too. But be careful, because there's actually 3 angles. And that's why we need to name them with 3 letters, because if I tell somebody, look at that angle in that picture, I'm telling you right now, look at that angle. Do you know what angle I'm talking about? Maybe not. So we have to be so specific when we name our angles. So let's say I'm looking at the first angle up here, this tiny one on top, okay? So my vertex must be the middle letter, okay? But I play dot to dot with it, basically. If I tell you to look at that, if you can't see where my pen just marked, I have to tell you, go to A, now go to B, and then to C, and now you're looking at the same place I am, okay? So I can call this angle A, B, C. Now that's that top angle. Now there's only one other way I can change that name. I could have started with C, then to B, then to A, so I could call it angle CBA. So I can flip-flop my letters. But no matter what, the middle letter is going to be that vertex B, okay? That's the one I need you to be able to see there. Okay, so there's one of my angles. All right, where's my second angle? Somebody says the bottom, down here, right? So I start at C, I go to B, and now I go to D. So I get angle CBD. Or I can flip it around and get DBC. Okay, so there's my second angle. So where's the third angle at? Well, don't forget, any of these, we can combine them together, and I can get this big angle. It goes right here on the outside, the whole thing, okay? The entire thing here. And so to get you to look at the whole thing, I would tell you A, to start there at the top. I still go to B, and then I go to D this time. So I have ABD, which is the whole thing, or angle DBA, because I can flip it around. Super, super important to name your angles with 3 letters. The middle letter must be the vertex every time, okay? If you don't name them with 3 letters, there's confusion, and you may not be talking about the same angle I'm talking about, and then we're going to be confused as to what we're looking at, okay? So let's go to page 2. Okay, at the top of page 2, it's, notice, just so you know, another postulate. And remember, these are rules that we just accept in geometry to say, yep, that makes sense, and we can use that rule. Okay, don't memorize them by the numbers. Just know that this is a rule. And this is similar to your ruler postulate, if you remember from the first section there. Actually, it was in 1.2. And in protractor postulate, it's basically saying we can use a protractor to measure an angle, okay? It says, consider ray OB, here's ray OB, and point A on one side of ray OB. The rays of OA, so if I make this one, it can be matched 1 to 1 with the real numbers from anywhere from 0 to 180, okay? And the measure of this angle AOB, notice O is my vertex, AOB, is equal to the difference between the real numbers for ray OA and ray OB. Now, a lot of mumbo jumbo there. Okay, I'm going to be honest, I don't know that I ever teach anybody to use a protractor where you don't start at 0. But in case your rays aren't starting at 0, you look at the numbers between them and you subtract them. That's what it means with this difference thing. Okay, so one of the things with when you use a protractor is please use common sense, okay? You'll notice on these protractors, there are two sets of numbers. There's numbers on the inside and there's numbers on the outside, okay? And so when you follow this right here, you fall on two different numbers, okay? So some kids will look at that and they say, I think it's on 68. And the other said, well, if it's on 68, then it's on 112 on the other number. Okay, well, which one of those numbers makes sense for that angle? When I look at that angle, I say, well, it clearly looks like it's bigger than 90. So if I need bigger than 90, I don't want the 68, I want the 112. Okay, so to be honest, if you just use common sense, you can figure out quickly where you should be and which number you should use. Okay, now, the other thing to notice is where did your zero start at, okay? When you look at this one, because you use the zero down here, your zero was inside, so we followed the inside numbers and we land on the 112. If you start from this side where the zero's on the outside, then you can follow the outside numbers and you would have landed on 68, but we didn't start on that side, okay? So there's kind of two different ways you can decide what you're using, but I would stress to you, use common sense. What does it look like that angle is? Okay? Now, as we look at these angles, we need to be able to classify them. I haven't done that move for a while. I'm trying to move my page. Okay. We need to be able to classify angles. And when we classify them, we put them in a group. Okay? So let's go over our groups before we do this next section. Here's the different kinds of angles I want to find. We have acute angles. Okay? This was in our vocab. These are angles that measure less than 90 degrees, right? So these angles look kind of like this. They're small, they're cute, right? Small things are cute, like babies and puppies and kittens. Those are cute. Then they grow up and who knows what they look like. But anyways, when they're small, they're cute. Acute angles are small, okay? Then we go to right angles, okay? These are exactly 90 degrees, okay? They look like the corner somewhere. Now, let me tell you this right now. Right now, if I drew that angle and I said what kind of angle that is, I wouldn't let you tell me a right angle. Because if I don't mark it with this little box, we cannot verify it is 90 degrees. It looks like it, but never ever assume. So make sure the box is in there, then you can tell me it's a right angle. Or if we're using the protractor, we can measure to see if it's exactly a right angle. All right, obtuse angles. Well, you know, in English, there's a lot of prefixes, suffixes that help you know what words mean and what family they go to. So, OB. What other word do you know that starts with OB? Yep, obese, okay? Obese, those are the fat things, okay? And this angle is definitely fat, okay? These are angles that are bigger than 90 degrees, okay? They're the fat ones. Obese, fat, okay? Obtuse, obese, they're big and fat, okay? So there's three of them. My last category is the straight angle. And the straight angle, remember we drew in here, it goes straight on each side. It's still an angle. There's a vertex there. It's this big angle here. And it's always exactly 180 degrees, okay? Now, we are always, and I should point this out, if you have an angle, we're always going to measure the shortest distance, so this distance in between here, okay? We're not going to measure from around. We're not going to go there. So every number we give in geometry for a measure of an angle will be 180 degrees or less. We're never going to go over 180, okay? All right, so let's try example 2 here and follow our rules and classify. So the first one I have is angle WSR. Remember, it's dot to dot. We go to W, we go to S, and then we go to R. Okay, now I'm going to follow these lines, and this is the one we're going to use, okay? When I look at WSR, let me see, RS is hitting, it looks like my 0 is on the outer scale, right? So I'm going to follow all those outer numbers there. And I'm going from here to here, and I'm trying to say, how big is this angle? Well, it looks like I'm hitting about 65 degrees. Does that make sense on that outer scale? So I'm going to say the measure of that angle is 65 degrees. What kind of angle is that when I classify it? Smaller than 90, so let's call that an acute angle. All right, next one. IC for B, TSW. So again, dot to dot, TSW. So it uses one of the same rays as our last one. We're talking about this big angle right here. How big is it? Well, again, my 0 here started on the inner scale, so I'm going to follow the numbers inside for that. And it looks like it goes about to 115 maybe on the inner scale. Okay, so that means my angle is 115 degrees. What kind of angle is 115 when I classify it? Looks like that's obtuse. All right, next one. We have angle RST, angle RST there. So I go to R to S to T. There's a chance I don't need a protractor for that one. It looks like that one's going to be exactly 180 degrees, and it looks like it's a straight angle, okay? Now, to be honest, which scale do you use? Doesn't matter. They'll both say 180, right? And finally, the last one, VST. You know what? I have more colors. VST. V goes here, now down to S, then over to T. I go straight up there. And once again, it doesn't look like I need my protractor too much there. I could use either scale, but obviously if it goes to the right, I'm on the inner. But it looks like no matter what, I'm going up to 90 degrees, which will make this a right angle when I classify it. Okay? So that's this type of protractor. I will teach you when you're in class to use the protractor on your geometer, okay? But right now, that's what we're going to use for that. If I put it on a quiz or test, I'm probably going to have it glued underneath, just like you see right here. So you're just reading the protractor you have. You probably won't have to use your geometer. For your homework, you can use your geometer, or try if you can figure it out, okay? All right, let's come down to the bottom here and do a couple checkpoints. It says on number 1, name all the angles in the diagram at the right. This looks similar to what we saw on the first page, and I think I have 3 of them, okay? So let's start with the one on the far left here. This first one, remember, it's a dot to dot. Where do I start? Where do I go? Where do I end? So I'm going to call this first one angle FGJ. Okay, I could also flip those letters and call it JGF, but G must stay in the middle, okay? Then I'm going to call the next one on the bottom here JGH, angle JGH. Again, G has to stay in the middle, and I can flip-flop it and call it HGJ as well. And finally, I'm looking for the big one that covers all of them. It's the entire thing, and it looks like I started at F, went to G, and then to H. So I call it FGH, or flip it and call it HGF. All right, next question. What type of angles do the x-axis, x goes this way, and the y-axis goes this way, form in a coordinate plane? Well, that's pretty easy, isn't it? How about a 90-degree or right angle? All right, let's move on to page 3. All right, I've got a lot going on here, stuff in the margin, and obviously another postulate, things like this. Okay, so are you ready for this postulate? It says if P, right here, is in the interior of angle RST, then the measure of angle RST is equal to the measure, RST goes this way, is equal to the measure of angle RSP and the angle of PST. So again, in symbols, if P is in the interior, then angle RST is equal to the measure of angle RSP plus the measure of angle PST. All right. Lots of mumbo jumbo. What is this saying? What we already know when we talked about segments. This is saying part plus part equals whole. So nothing new here. This part plus this part equals the whole thing. That's all this is saying, okay? So we can treat it just like we did with our line segments. We can do this now with the angles. Okay, so I can't stress enough, when you get a picture, label everything you know, okay? So I have this diagram over here. They already put 4x plus 4 and 4x minus 1 there. But they tell me right here in the directions, GFJ equals 155. So GFJ, that's the whole thing, equals 155. I'm labeling it in my picture so my brain can see what they're actually talking about. They want me to find the measure of GFH, that's this small one on the left, and HFJ, which is the small one on the right. Okay? It's a picture, right? I look at the picture and say, wait, that's a part plus part equals whole, right? So they called the whole thing GAFJ, JFJ. We can call the left side GFH and the right side HFJ. And now let's do some plugging and chugging to solve for x. The whole thing is 155. GFH on the left there is 4x plus 4. And HFJ on the right side is 4x minus 1. So we get a part plus part equals whole. Let's go ahead and solve. On the right side, simplifying that down, it looks like I have 8x. And it looks like I have positive 3 equals 155. Solving for x, I subtract 3. 152 equals 8x. Divide by 8. Does it come out equal? It does. 19. Okay. So now just be careful. We solved for x, but what did the question ask us for? It didn't ask us for x. It said, can you find the angles? So let's go ahead and plug it back in for both. GFH was 4x plus 4. I'm going to plug in the 19. So 4 times 19 plus 4. Well, 4 plus 19 is 76. 76 plus 4 gives me an 80. Okay. Let's do the 4x minus 1. I'm going to do 4 times 19 minus 1. So I get 76 minus 1, and I get 75. So I get angles of 80 and 75. So quick check, what is part plus part? I add my parts together, and I get 155. And guess what? That matched my whole from up here. So it looks like we're on the right track, and we did what we should. Okay. So let's go ahead and go to the bottom of the page here to do the next checkpoint. All right, it says angle VRS is a right angle. Well, guess what? My whole is 90 degrees, right? That's what a right angle is. So we're going to find angle VRT and angle TRS, the small ones that make it up. So once again, I'm thinking part plus part equals whole. Well, what's one of my parts? X minus 4. What's another part? Oops, I need a plus in there. 3x plus 2. And it equals the whole 90 degrees. Combine my x's, I get 4x minus 2 equals 90. Add my 2, I get 92. Divide by 4, and x is 23. But it asked me for the angle, so I'm plugging in. So for VRT, which is the one there on the top, which was x minus 4, I'm going to go 23 minus 4, which is 19. And then angle TRS is 3 times 23 plus 2. So I get 69 plus 2, which equals 71. What is 19 plus 71? 90, because part plus part equals whole. All right. Don't turn the page yet. We've got some in the margin we need to look at. Okay. I do believe mine might look slightly different than yours, okay? Don't panic. They're really, I tried to make them the same, but I think I tried to draw them myself, so they look a little funky there, but we'll work through it. Okay. So you might get something in your homework that looks like this top diagram, and they gave me one angle 74. And because it's our first time looking at angles and stuff, sometimes our brain freezes up, and I'm like, well, what do? I don't know what to do here, okay? Well, my hint to you is to think of this, okay? What kind of angle, opposite angle, here these goes each direction, right? What are they doing here? And what I see is a straight angle, okay? So I need to find what this angle A is. Well, if this is a straight angle, we know the whole thing is 180 degrees. So A plus 74 equals 180. Subtract my 74, and A is going to equal 106, okay? So I can put my 106 now in my diagram. It's time to solve for B. Oh, this might be the one time I'm glad I'm not sitting with you in class, because I know somebody over there has already told me what B is because you think you know it. Chances are you do know it. But we are going to play dumb because that vocab is coming on the next lesson. So we're going to play dumb on that one. But I'm going to tell you, look, lines don't have to only go horizontal. This is a straight, oops. Can I get rid of that? Oh, this is not good. Okay, let me see if I can get rid of this. this is how we're getting rid of it, okay? Because I don't know how to fight this right now, so we're just going to move it over there. Okay, go back to my green pen. This is also 180 degrees, okay? All of this. So I could say A plus B is 180. And if my A was 106, I can now subtract that 106, and I can get 74, okay? Now, I know some of you are doing it a different way, and I know some of you got 74. That's great, okay? Go with it. Excuse me. There's one more. Excuse me. Okay. Let's look at the bottom diagram. Okay. Let's see. Lots going on here. I've got some right angles. That's important. And what should be important, make sure you know this, that if this side is a right angle, because this is a nice straight angle, this side has to be a right angle too. And what that allows us to do is solve for C, because now we know that C plus 23 equals 90. I subtract 23, and C is going to equal 67. Okay, so I can put 67 there. Okay, now let's look for D, and I do want to make sure you understand that D is actually starting here and going all the way to here, okay? So it's this angle here that I'm looking for, this D, okay? I know it's more than 90 because it definitely looks obtuse, and we can do more than just assume that. We can trust that because we know there's this 90 in the middle, okay? So what I would stress to you is look at this nice straight line, right? And this whole thing is a straight angle, so that should make 180. So if I go D plus 23, I should be able to make 180. Subtract 23, and D is going to equal 157. So I get 157 in there for D, okay? Are there more than one way to find these? Definitely, okay? So just keep in mind that those straight lines make 180, and that will help you with a lot of these. All right. Last page, and I'm going to, excuse me while I blow my nose, so hopefully I don't sneeze again. All right, top of the page here is where we want to be. On this picture, I have this quadrilateral four-sided shape, and it says identify all the pairs of congruent angles in the diagram. Now, what are congruent angles? Angles of the same size. How do I know if they're congruent angles? Well, don't forget that when we had a segment, we had these little marks, okay? It's really hard to put those marks on angles. So you're not going to find those marks on an angle. What you find are what we call these arc marks, okay? So this N has one and this P has one, and because they both have one, they match, and those are congruent angles, okay? So angle P is going to be congruent to angle N because they both have one mark. Now, I know we didn't quite get into it yet with segments, but sometimes you can put a double mark. As long as they have the same marking, they are congruent. Same thing goes with an angle. So if I have 2 marks and 2 marks, angle L is congruent to angle M, okay? So you find these congruent markings, and you know those angles are exactly the same size. They told us angle P is 120 degrees, so what's angle N? Well, if angle P and angle N are congruent, then their measures are also equal, and angle N is also 120 degrees, okay? So congruent markings look a little bit different in an angle than they do on a segment, but the meaning is still the same thing. So look for the little arc marks. Those make congruent angles. Okay, I say that, and let's look at this next picture because sometimes there's a lot of confusion here. All right, so I have this picture here of angles with that vertex there at W. Do they have any congruent angles marked? And I often get a lot of people that say no. Those do not look like the same congruent marks. Okay, I'm going to do my best to draw this picture. And you have to think about what I'm doing. And I can't even guarantee I'm going to be a great artist here, so I don't know if I'll make my point. Here's my angle, okay? I'm going to split it in half. So I put this line straight down the middle. Okay. Now, if I go to make a congruent mark and I say I want this one here congruent to this one here, and I keep going so they're the exact same size. And I come back next week and look at this. Is that 2 different marks or is that one full mark? I don't know. That's where it gets confusing because I don't know if that's one big line or if it was two separate. So when they draw them in an angle, they, especially if they're side by side, they stagger them. They might put this one up here and this one down here. The key is both of them have one mark. If they both have one arc mark, they are congruent. If they both have two arc marks, they're congruent. So the key is not that the arc marks look identical. The key is that the arc marks look like the same number of arc marks, okay? So when you look at this picture here, yes, those are congruent angles. Even though they're staggered, they staggered them so we know they're different. There's one in the top angle and one in the bottom angle. That's why they staggered them, okay? But they are congruent. The other hint we have on this problem is we have this word bisect. It tells us in there that ray WY is bisecting the angle, which means it's cutting it in half, right? So it tells us XWY, dot to dot here, XWY, that's this one on this side, is 29 degrees. What is angle XWZ? Now be careful, XWZ is the whole thing. So I'm thinking a little part plus part equals whole, right? And if this side's 29, this side has to be 29 because it's bisected, which means I'm going to do 29 plus 29, and I'm going to get 58 degrees. You'll notice I skipped quite a bit of that work there because sometimes it gets so hard to figure out what they want me to fill in, okay? Part plus part equals whole, right? That's what we see here. And we get 29 plus 29 is 58 because it's bisected. So while we're at it, let's go to the margin, okay? Right here in the margin is one you might see similar to this in your homework tonight or on your test or quiz coming later up. I have segment ray BD right here is bisecting my angle, okay? As soon as I see bisect, this is equal to this, okay? So arc marks there, they're equal. Not only that, I'm going to set up part equals part, okay? Yes, I know part equals part here, but I needed the whole thing, so I did part plus part equals whole. Here, I need part equals part to solve for x. So I'm going to plug in for the left side, 5x plus 16. It equals 8x minus 23. Okay, I'm getting my parts together, so I'm going to subtract 5x. And 16 is going to equal 3x minus 23. Add 23 to the other side. 3x equals 39. Divide by 3, and x equals 13. So I'm done? No, I'm not done. I need to plug it back in because they've asked me to find the measure of angle ABC. So I need a number here. So I go to ABC. Well, that's the whole thing. Notice ABC is the whole thing. So I need to plug it in both sides. So I'm going to do 5 times 13 plus 16. Well, 5 times 13 is 65. 65 plus 16, that looks like it makes about 81. Let's plug it in over here. 8 times 13 minus 23. So 8 times 13, that's 104 minus the 23 gives me 81. Should we get the same number? Definitely, because we bisected it. They should be exactly cut in half. But I still need to answer the last question, the measure of ABC. Notice I put M out here when I want an equal sign, when I want to make it equal a number. And if the M is not out there, it's congruent signs because I'm just talking about angles, okay? Just a side note there. So the measure of angle ABC is 81 plus 81, which will give me 162. Okay? All right, a couple more to do at the bottom here, and we're good for these notes. All right, number 4 says, identify all the pairs of congruent angles in the diagram, and then find some measures. Okay, so I'm looking for arc marks. Angle A has 2 arc marks, so that means it is congruent to angle C, which also has 2 arc marks. Notice here, my names and my angles are congruent because angles are congruent. If I gave numbers, I'd make them equal. All right, what else? Angle B is congruent to angle D because they both have 1 arc mark. Now, it tells me the measure of B is 135. So what is the measure of D? Because I put this M out front, I'm finding a number, and it's now equal, not congruent. And if B is 135, D also has to be 135 because they have the same markings, okay, or same arc marks. All right, last one here. It says that we have KM is bisecting LKN. LKM, when I do this, LKM is 78 degrees. Find LKN, which is the whole thing. Well, if it's bisected, if this side's 78, this side also has to be 78. So if I want the measure of LKN, which should be a number, right? I'm going to do part plus part for the whole thing. And 78 plus 78 will give me 156. Okay? It asks me for the measure, it equals a number. If it's just the names, they are congruent. Okay? So that's angle measure, okay? You'll notice that when we did segments, we did one day on part plus part equals whole, and then we did a day where we added in the midpoint and we did part equals part. Today with angles, we just did them all together. We got the part plus part equals whole and the part equals part thrown in here. So just remember, part equals part when you find that bisect word, okay? Or if you look at the diagram and it has matching angle marks, okay? Otherwise, your part plus part equals whole. So for homework, we are in the book, okay? And you're just looking to do any of the, I need to adjust this. I like kind of throwing this out here. Page 28 through 30, 4 through 42 evens, show your work, okay? I think I need to double check on your calendars. I may have made a mistake on a calendar here. So definitely go with this one, page 28 through 30, 4 through 42 even. Show your work where you need to, okay? That's 20 questions. It's not too bad, right? Give me email if you're not sure on something.